Good day everyone, I'm Akshat Guneshilan and going to be presenting the paper ID 11 with the paper titled SBRIR, a strategic block recommendation framework employing integrative learning reasoning paradigm. This paper has been done by Akshat Guneshilan and Gerard Deepak. Abstract. This paper introduces a novel approach for blog recommendation in the Web 3.0 era, addressing gaps in traditional frameworks. It focuses on semantics-driven recommendation by enhancing query words and dataset terms through knowledge aggregation. It utilizes repositories such as NEL and CYC to boost the richness of pre-processed query words and enrich dataset keywords. It employs dynamic knowledge stack generation for exponential aggregation of auxiliary knowledge from various sources and achieves a best-in-class performance with 95.42 precision, 96.17% F measure, and a low FTR of 0.05, outperforming other baseline models. A blog is an online platform presenting content in reverse chronological order encompassing text, images, videos, and reader engagement features. It serves various purposes ranging from personal expression to professional branding. Popular platforms like WordPress, Blogger, and Medium are utilized, and some blogs monetize through advertising. Microblogs, exemplified by Twitter, prioritize concise communication and real-time discussions with character limits. Blog recommendations employ advanced algorithms to analyze user behavior, improving the user experience by providing contextually relevant suggestions tailored to individual interests, leveraging semantic content understanding in the Web 3.0 era. Motivation. The proposed strategy is motivated by the absence of Web 3.0 compliant models for blog recommendation. With the substantial growth of blogging and an increase in number of web users and bloggers, there is a pressing need for an effective blog recommendation framework. Blogs are viewed as web documents, and the unique requirement for blog topic coherence linking distinguishes it from traditional document recommendation. The driving force behind this paper is the lack of a knowledge-centric and semantically oriented framework for blog tag recommendation in compliance with the Web 3.0 standards. The primary contributions of this paper are the proposed framework incorporates novel elements including the utilization of Wikidata and DBpedia for knowledge enrichment. Classification is conducted using transformers and the XGBoost classifier, introducing feature-controlled classification for dataset analysis. Semantic reasoning is elevated through the integration of the Horn's index, Kullback-Leeuwen divergence, Bose-Einstein index, and the second-order co-occurrence pointwise mutual information (SOC-PMI). The Mayfly algorithm is employed to optimize results, ensuring compatibility between query words and dataset terms. The framework demonstrates improved precision, recall, accuracy, F-measure, and reduced FTR compared to other baseline models. The main base paper for this particular paper was the paper done by Liu et al. This paper introduces MCSS, a system for tailoring blog content delivery to mobile users. It predicted popular topics using trend analysis and personalized user interests from browsing behavior. Experiments showed that MCSS effectively delivered preferred blog content, enhancing mobile commerce strategies and shedding light on web blog dynamics and content personalization. Second paper is the one done by Wang et al. This focused on personalized recommendations and highlighted the limitations of prevalent models based on user tag and social connections. This approach integrated user following and microblog reposting relationship. Empirical results showed significant performance improvement, addressing data sparsity and the cold start problem. The third one is by Gao et al. This paper explored the significance of blogs as platforms for personal expression and intercommunication. The method was evaluated against traditional blog similarity-based approaches, showing significant enhancement in recommendation quality and rationality for improved blog discovery. The proposed system architecture. So the main proposed system architecture follows two paths. That is, from the dataset of blogs, we extract keywords and categories, and this again branches out into two. After extraction of keywords and categories, the first branch is enriched by the Wikidata knowledge repository, then enriched by the DBpedia knowledge repository, and then used to compute SOC-PMI under the Mayfly algorithm. The second path is again enriched by the Wikidata knowledge API. The load dynamic knowledge stack is done, and this is enriched further by web pages, online documents, and ebooks, along with the Wikidata API, and then they are classified using a transformer. Then the classified instances are further subjected to enrichment by the NEL repository and the CYC knowledge repository, which is again used to compute SOC PMI under Mayfield algorithm. Again, from the Mayfield algorithm, there are two divergent branches. One is the optimal intermediate instances are evaluated, and then the Kullback-Leibler divergence and the Bose-Einstein's index is calculated. A third uh, A third branch is from the user input query. The query pre-processing happen, NEL CYC enrichment, and back to Kullback-Leibler divergence. These two are then used to compute the most relevant facts. These most relevant facts are used to compute the Horn's index. The Horn's index is also enriched by the classification of the dataset directly through using the XGBoost classifier. And once Horn's index is computed by all the other enrichment, finally the rank is recommended and sent back to the user. If the user is not satisfied, he can again do the entire process to get back a better rank as supposed by the user. This is the main proposed system architecture. Implementation. Experiments utilized a consolidated dataset from 3 distinct block datasets with meticulous annotation and strategic rendering. A customer web crawler expanded the dataset's coverage using terms and annotations. All experimental trials were conducted exclusively on this unified single large integrated dataset, merging previously independent datasets for comprehensive analysis. The framework and baseline models underwent rigorous experimentation in a controlled environment involving 1,244 queries collected over 60 days from 144 users. The enhanced ground truth was created using users' preferred search engine queries and top 5 blog titles, ensuring equivalent conditions for performance assessment. These are the main performance metrics. That is, the accuracy was calculated as the sum of the precision and recall divided by 2. Precision was the number of relevant and retrieved web blocks divided by the total number of retrieved blocks from the query. Recall was the number of relevant and retrieved blocks divided by the total possible relevant blocks. F measure is 2 into recall into precision divided by the sum of recall and precision. And the false discovery rate is equal to 1 minus the value of the precision which was obtained. The precision percentage was the number of recommendations for the block recommendation for the frame SBRIR proposed framework, and compared to the other baseline model is shown in this graph. We can see that the SBRIR occupies the highest position and is the best performance compared to the BRBSM, PMRRR, and the PRMA models, and again shows us that this is the best in class method for block recommendation and microblog recommendation. The performance analysis of the SBRI model as proved by the graph is again given in the table here. You can see that the SBRIR model has the highest average precision with 95.42%, highest average recall percentage with 96.93%, average accuracy percentage with the highest value of 96.17%, highest average F measure value of 96.17, and a false discovery rate of the lowest value compared to the other baseline models of 0.05. This paper introduces the SBRIR model, a knowledge-driven blog recommendation system integrating learning and reasoning. Knowledge density is strategically enhanced using repositories such as the Wikidata, DBpedia, NEL, CYC at both the dataset and query levels. Dynamic knowledge stack generation incorporating web pages, online documents, and ebooks further boosts knowledge density. Transformers are employed for classification, improving the learning infrastructure and overall model relevance. Semantic similarity measures like Horn's index, second-order co-occurrence pointwise mutual information, Bose-Einstein statistics, and the Kullback-Leibler divergence facilitate semantic inferencing, resulting in an impressive average recall of 96.93%, average accuracy of 96.17%, average F measure of 96.17%, and a false discovery rate FTR of 0.05, positioning it as a top performing model among baselines model for block recommendation. Thank you.